Today, I'll explain how light alters our biological watch and melatonin production. Have you ever struggled to fall asleep after checking your phone in bed? It's not just TikTok keeping you awake, there's real neuroscience behind it. The reason we stay awake during the day and sleep at night comes from our internal biological clock, called the circadian rhythm. It runs on a 24-hour cycle and controls things like sleep, body temperature, and hormones. Light and darkness are its main regulators. When sunlight reaches the eye, light-sensitive cells send signals to the suprachiasmatic nucleus, a small region in the brain that acts like our master clock. This clock regulates the release of melatonin, the hormone that makes us sleepy. During the day, exposure to light, especially blue wavelengths, suppresses melatonin and promotes alertness. At night, darkness allows melatonin to rise and pressure us to sleep. But when we use our phones at night, the light tells the brain it's still daytime. Melatonin stays low. It takes longer to fall asleep, and sleep becomes lighter. Poor sleep quality caused by blue light exposure doesn't just make us tired. It also affects mood regulation, attention, and emotional processing, which are key for learning and mental well-being. During the night, we go through 4 to 6 sleep cycles. Each cycle lasts about 90 minutes, approximately. Each person is different, and even the same person can have different cycles each night depending on what their body needs more. It starts with light sleep, N1 and N2, continuing with slow wave sleep, N3, and ends with the REM phase, where your brain shows activity patterns similar to when you're awake, even though your body remains paralyzed. Slow wave sleep repairs the body, while REM sleep strengthens memory and emotions. As the night goes on, slow wave sleep decreases and REM sleep increases. Blue light exposure before bed can delay REM and fragment these cycles, so even if you sleep the same number of hours, your rest isn't as restorative. Now let's look at 2 experiments that tested this effect in real people. The first one, effects of pre-bedtime blue light exposure on ratio of deep sleep in healthy young men, by Itzawa and colleagues, published in 2021. They exposed 11 men to 3 light conditions before sleeping: warm light, blue light, and blue light with blocking glasses. The light conditions were rotated between participants, with breaks in between to avoid bias. Using the same people in all tests helped control differences like sleep habits or metabolism. The results show that blue light before bed doesn't reduce total sleep time, but it makes sleep less restorative by significantly decreasing slow wavelength sleep. The second study is called Acute Exposure to Evening Blue Enriched Light Impacts on Human Sleep, published by Kahochen and colleagues in 2013. Exposed 30 young adults to blue-enriched and warmer light 2 hours before bedtime. The researchers found no major differences in the total amount of REM and non-REM sleep during the first 3 sleep cycles. However, they found less slow-wave activity, meaning less deep rest, under blue light. In conclusion, light doesn't just let us see, it tells our brain when to wake up and when to rest. The studies I've mentioned show that blue light before bed can delay melatonin production and alter our sleep architecture, reducing the quality of our rest. So if we want to support our biological clock, one of the simplest things we can do is limit screen exposure before bedtime and allow our brain to experience real darkness.